we saw how an electromagnetic wave can be produced, right? So Hertz did it, and lot of other scientists also did the same thing. Now, see, once we have an electromagnetic wave, so what are certain properties, like what is the speed of an electromagnetic wave? What is the energy of an electromagnetic wave? Lot of these properties and lot of other things what we have to know about an electromagnetic wave. So first thing, let's start with the speed. So to figure out the speed, so what we have is, see, we have both electric and magnetic field which are perpendicular to each other, correct? And the direction of propagation of the wave is perpendicular to both electric and magnetic fields. Now suppose, let's say we have E to be the electric field, then we have E is equal to E naught sine of omega t minus k. So k value is basically 2 pi by lambda, and we have the magnetic field which is B. B is also equal to B naught sine of omega t minus k. So what we have is, we have E and B which are in phase with each other, and they will be moving perpendicular to each other. Alright, so using this, what we can actually tell is that the value of the speed of an electromagnetic wave, so we represent that as C. Since we have both electric and magnetic fields here, we get the two important constants, that is epsilon naught and mu naught. Okay, now always remember, epsilon naught is a constant which is related to electric quantity, and mu naught is a constant related to magnetic quantity. So since we have both mu naught and epsilon naught, so what we have is C is equal to 1 by square root of mu naught into epsilon naught. So this is the speed of an electromagnetic wave. Okay, since even light is also an electromagnetic wave, we have this particular formula. Two scientists in 1887, Michelson and Morley, so they actually designed an instrument to measure the speed of light, and by their calculation it was coming up to 2.99 into 10 to the power of 8 meter per second, which we rounded off as 3 into 10 to the power of 8 meter per second. So the value of 1 by square root of mu naught into epsilon naught, see, this value was 3 into 10 to the power of 8. Now one important point is, mu naught and epsilon naught is for vacuum, correct, or what we call it as free space. Now what if we have certain medium? Then we will have V is equal to 1 over root of mu into epsilon, where mu and epsilon are the relative permeability and permittivity of the medium. Okay, now using this, so we figured out the speed of an electromagnetic wave, right? Now we have energy of an electromagnetic wave. See, energy of an electromagnetic wave is given by U is equal to P divided by C, where P is the momentum. Okay, now even if you keep your hand in sun, electromagnetic waves are coming and hitting your hand. Actually, that's basically the light and the warmth what we feel. So since these two are electromagnetic waves, and we need to figure out how our hand does not feel any pressure, because see, if any electromagnetic wave has an energy and it's coming and hitting our hand, then we need to feel that pressure, correct? Why we don't feel that pressure is because the value of C is very high, right? So we have U is equal to P divided by C, where P is the momentum. So the value of C is extremely high. So the energy whatever we have, that becomes very, very small. Okay, so even though those particles, the waves are coming and bombarding our hand, we don't feel that pressure. We don't feel that something is pushing our hand. Okay, so what we get is that an electromagnetic wave has a very high speed, which is 3 into 10 to the power of 8, and it has, even though it has very high energy, we don't feel it because that momentum becomes very, very small. Okay, so the value of U, the energy, is P divided by C. Right? So taking these two into consideration, we have lots of other properties for an electromagnetic wave. Okay, like we have energy density, and then we have different forms of the same energy itself, but in different forms. So these things you'll be seeing in the next video.